Hey guys, hopefully you've been working on these fraction worksheets already. This video is just going to help either reassure you that you're doing it correctly or maybe nudge you in the right direction if you weren't quite filling them out correctly. So on our first page, we're really just making a connection between the written equations, these like fraction plus fraction plus fraction, and the visual. Notice that all of the problems that we're working on this first page, they all have the same denominator. So each of the fractions we're adding, these are all unit fractions with the same denominator. So that's awesome. And all of our pictures represent that too. Each of the partitions of the rectangles are the same size. So for example, in the picture for part B, we have 4 shaded fractions out of a total of 5. So each one of these is like 1/5. And that we're adding 1/5 4 times. So you would look for that expression on the left-hand side of the screen, which looks like it's right here at number 3. So number 3 matches up to B, and you would just draw a line to show that those are the corresponding expression and visual. On the next page, we are just rearranging like leftover pizza in a box. So we have, in the example that we're given, the pizza is cut into a total of 7 slices. 3 of those slices were colored in. The second pizza was cut into 7 slices as well. 2 of those were colored in. So then we fill in the final circle. We have 3 from the first box, 2 from the second, and we can see that out of 7 slices, we have 5 of those colored in. You'll do the same thing for the rest of them. So you're just going to copy the shaded slices into the final answer circle, and then read that as a number of shaded pieces over the number of total pieces in the circle. On our next page, on this one, basically it's hoping that from those last 2 models that you made a connection between adding unit fractions and what the result is. So in each of the previous pages, we're adding unit fractions together, and you're really just counting the number of pieces. So you're counting the number of unit fractions that you're adding, and that becomes your numerator. So in problem 1, for example, on this third page, we're adding 1/9, 1, 2, 3, 4, 5, 6 times. Which means if we were to count each of the colored in pizza slices or colored in rectangles, we would have 6 of those fractions colored in, and they would fill in 6 of the 9 in the visual. So now that we've gone through the models, we can quickly count these and just say, oh, I'm adding 1/3 2 times, that's going to come out to be 2/3. I'm adding 1/4 2 times, that's going to come out to be 2/4. At this time, we are not reducing our fractions, we're just getting used to adding them. Using those pizza models, we were able to interpret what it looks like to combine fractions that aren't unit fractions, meaning the numerator is no longer just a 1, it could be a 3 or an 8, or etc. And so really we're just looking at what we're calling like fractions, fractions with the same denominator, and we're only changing the numerators when we do addition and subtraction. The denominators are not changing. So every time you are adding or subtracting like fractions, really you can just copy over the denominator because it's not going to change. And the only math that's going to happen is between the numerator terms. So 3 minus 3 would give us 0, 8 minus 5 would give us 3, 3 minus 2 would give us 1. Now in this problem, it is asking us to write our answer as a mixed number fraction if possible. And remember that for any fraction that's improper, so the numerator is larger than the denominator. So something like 10/7 is an improper fraction. We call it improper because the reality is we only need fractions for situations where we're talking about less than a whole number, right? We wouldn't talk about fractions if we're talking about the number 10. We don't need a fraction there. So looking at 10/7, that's actually improper because we have enough to make one complete whole, but then we would be left over with 3 pieces. So we would look at this as 1 3/7. Those are equivalent values. One of them is an improper fraction, the other one is a mixed number. So hopefully that makes enough sense for this page. Let's move on to the next one. For these ones, we are doing improper fractions. Notice they are still like fractions though, so it really will be very similar to the last page, but note that the instructions are saying to write your answer as an improper fraction, so you're not going through the trouble of converting it into a mixed number. Now, some of these visuals are going to be easy to understand based on the example that's given at the top of the screen, but some of them, I'll admit, aren't that clear. So hopefully we can clarify those for you. In this visual, we're using mixed numbers, and it's very similar to the pizza example that we did in the beginning of this work packet. So let's kind of relate it back to that. Now, the problem that they are demonstrating is 1 3/5 plus 2 4/5. And it's using 1 3/5 in green, colored in, and then the 2 4/5 is being colored in with blue. So we're color coordinating these. And it recommends that the first thing you do is to color in the whole number parts. So from the 1 3/5, we have a 1 colored in, so a whole circle colored in. From the 2 4/5, we have 2 complete circles colored in. And then next you're going to fill in the fraction amounts, putting all of the pieces into a circle until it fills up, then you can move into the next circle. So from the 1 3/5, there were 3 green slices colored in. From the 2 4/5, there were a total of 4 blue slices colored in. And then at the end, we just count up what we have. There's a total of 4 complete circles. So that's why our final answer has a 4 as the whole number. And then from what's left over, we see 2 slices in this incomplete circle, so our fraction part would be the 2/5. So I can demonstrate one more down here just for an extra example. So let's try and do problem number 1. I'm going to start off by coloring in the number 1 2/10 in green. So the whole number part, the 1, I'm just going to color in this whole circle. And I'm not going to do a super terrific job here. Don't worry about making it perfect, but make it clear that you've filled in the full circle, that none of the slices are incomplete. If you really wanted it to be prettier than that, maybe we just scribble in all of our slices here. That's up to you. I'm not going to be too picky. As long as the entire circle is shaded, then I will call that good. All right, and then from the 3 6/10, there are 3 circles colored in. I'm just going to do a big spiral here to represent the whole number 3. 3 of them are colored in. Now let's go back and start to do the fraction parts. So we have 2 out of 10 that should be green. So the circle is already cut into 10 slices. I'll just color in 2 of them. And then from the 3 6/10, I need to color in 3 of those slices in blue. And then we can count what's left. So I can see that I have a total of 4 complete circles, so my whole number would be 4. And then out of the 10 slices, 4 of them are shaded in. And maybe you recognize that we have an entire half circle shaded in. If you want to simplify that, I won't mark you off. If you don't simplify it now, I won't mark you off either. I'll let you use your creative freedom there. Oh, I wrote 4/10, but guess what? That's 5 shaded in. Let's fix that. I was just thinking to myself, 4/10 is not equal to 1/2, but that's okay. We can see them visually. It is a half a circle, and we can count the shaded in slices. There's 5 of them. So you'll do that for the rest. These problems at the bottom of the page that are being interrupted by these commoncoresheets.com thing, if it's too hard to read, skip it. I'm not going to take points off for it, but make sure that you do all of the ones that are completely legible. All right, subtracting mixed fractions. Now, the model is similar to what we just did with addition, but there are some differences, so let's make sure that we can understand them. The first step is to start with your first number and represent that visually with your cut up circles. So we have 4 full circles colored in, and then 3/5 of a circle colored in. And then we are trying to subtract 2 and 4/5. Well, that color does not show up well. Let me switch to a green. We're subtracting 2 and 4/5. So we're going to go back to our picture and we're going to cross off 2 full circles. And then we're going to cross off 4 slices out of the 5 slice circle. And it doesn't matter where you cross them off. Now, I will recommend that you start with your most incomplete circle first. So rather than crossing off the 4 slices here, you should start by crossing off the incomplete circle here because it'll make it more, it'll make it easier to rewrite this as your final answer. So after I've crossed everything off, I can count what's left. There is 1 complete circle left over, and then there are 4 slices that have not been crossed off. Each of those slices is 1/5 of a circle. So 1 and 4/5 would be our final answer. Let's do one more just to make for good measure. So problem number 1, the 6 and 4/6, we'll start off by coloring in 6 circles. 1, 2, 3, 4, 5, 6. And then we have 4 slices colored in out of this partitioned circle. And then the problem asks us to remove 4 whole circles and 5/6 of a circle. So I'll cross off 1, 2, 3, 4. And then I'm going to go to my incomplete circle over here. I need to cross off 1, 2, 3, 4, 5. I need to cross off one more slice. And the way that I have my full circle colored in, it doesn't look like I can, but just like we learned how to regroup things earlier in the semester, we can do that with our partitioned circles. So let's look at this last circle as if every slice was cut. And now it's clear that I'm able to remove one of those pieces. And then we can count what's left here. I have 1 complete circle, and we have 1, 2, 3, 4, 5. Oh, I accidentally erased one of my. There we go. So we've removed 5 slices and we have 5 left behind. So 5 out of 6 left behind. These visuals are helping us to realize the process that we're using when we're subtracting fractions, where the fraction parts aren't, let's see, the fraction that we're subtracting is larger than the fraction that we're starting with. So notice that in that first problem we did 4/6 minus 5/6, and we're doing a big number taken away from a small number, which when we learned negative numbers, we said, oh, well, that would just be a negative number. But in our visual, we were able to see that there was plenty there to borrow from with the whole number. So we just took our whole number and broke it up into fraction pieces so that we could subtract the appropriate number of pieces away. After we do this full page of visual models, it should make it easier for us to understand how to do the purely arithmetic process. So first thing we notice is 2/4, 3/4. This number is too big to take away from 2/4. So I would need to cut into our 9 circles, make that 8 circles, and then I'm going to take that extra circle to make the 9, and I'm going to cut that into fractions. So instead of calling it a 1, I'm going to make it look like 4 out of 4 pieces. I still had those other 2/4 pieces. And now when I combine those, I can write that as 8 plus 6/4. 6/4 has plenty of slices for me to take 3 of those away. So now when I do minus 6 3/4, we can do the whole number part, 8 minus 6, and the fraction part, 6/4 minus 3/4. So that we get 2 3/4 as our final answer. A common mistake for problems like this is to not borrow from your whole number group and to combine your fractions incorrectly. So let's find another example where that would happen, like in problem number 4. If I were to jump straight to the group together the whole number parts and group together the fraction parts, if I didn't recognize that my fraction parts would give me a negative number, I could get myself into trouble. So 7 minus 3, no problem, that's 4. 3/8 minus 6/8. Now that we know about negative numbers, we might just call that negative 3/8, which technically is fine, but you would then need to take into consideration that you have a positive 4 and a negative 3/8. So we would need to subtract 3/8 from that 4. And if you notice, that can kind of get cumbersome. So rather than jumping straight to separate the whole number part and the fraction part, we want to make sure that if our fractions, if we're subtracting a fraction that's larger than the fraction we're starting with, that we tap into the whole number to borrow or to regroup. So the correct way to do this problem would have been to say, hey, the 6/8 is too big to take away from the 3/8, so we're going to regroup the 7 into 6 and 8/8 plus that 3/8. So that would actually become 6 and 11/8, which we don't write mixed numbers like this. We do not like to write mixed numbers with an improper fraction, but for the sake of demonstrating subtraction here, it's okay. So then 6 and 11/8 minus 3 and 6/8, we can easily separate the whole number part and the fraction part. And then finish that off by saying 6 minus 3 is 3. 11 minus 6 would be 5/8. So our final answer would be 3 5/8. All right, so make sure you work on that. Ask questions if you get confused on any of these. Happy to help you. Here's some more workout problems. This one is requiring regrouping, just like the last page had some. All right, here's another visual that I really like, and this is where we jump into fractions that have different denominators. And you're probably really familiar with the concept of least common denominator. And this is not going to guarantee that you find a least common denominator, but it will help you visualize what's going on. So each of the numbers that we have in our subtraction problem are represented as a rectangle cut into vertical squares or horizontal squares, depending on which one we're looking at. So 4/10, we took a rectangle or a perfect square and cut it into 10 horizontal strips. And then 1/3, we cut those into vertical strips. We have 3 strips, one of them shaded in to represent 1/3. And what we're going to do is imagine that these overlap each other. So I'm going to take that 1/3 and I'm going to copy it onto my 4/10. And then I'm going to take my 4/10 lines and imagine that I can copy them over here onto my 1/3. Now, I'll admit that our pictures aren't going to be perfect here, but it's a nice visual. How many do I have here? 1, 2, 3, 4, 5, 6. There we go. We've got 10 strips over here. So now all of our pieces are equal size. So our 4/10, instead of writing it as 4/10, we can write that as the number of shaded pieces over the total number of pieces in the box. So let's think about what the total is in each box. There are 10 rows, and each of those rows was cut into 3. So it's really like adding up 10 3 different times, or 30. So each one of these slices is 1/30. Our 4/10 turned into 1, 2, 3, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So instead of 4/10, we're writing that as 12/30. And instead of 1/3, we're going to write that as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10/30. Now they have a common denominator, so we can go ahead and carry this out just like we did earlier in the chapter. 12 minus 10 would be 2/30. So this visual, this page, is helping us to create common denominators. Now, in this case, we did happen to find the least common denominator, but we're not going for the least common denominator on this page. We're just finding a common denominator that will help us talk about combining fractions that were originally represented with different denominators, but we can't combine them without creating a common denominator. Let's do one more just for good measure. Problem number 2. So we have 2/4. That's represented in this first picture. And then we have 2/6. That's represented in the second picture. And notice that we're always using horizontal cuts for the first fraction, vertical cuts for the second fraction. And that's so that we can copy them over. So I'm going to copy the 6 vertical cuts onto the first picture. Make sure that we cut that into 6 slices. 1, 2, 3, 4, 5, 6. Perfect. And then we're going to copy the 2/4 over into the other picture. Oops. So I need to cut the 4 horizontal cuts. Now all of our cuts are the same size, so we can go back and say, all right, how many pieces are in each picture? Well, we had 4 horizontal cuts, and each of those was cut into 6, so that would give us 24 total pieces. So instead of 2/4, we're going to have, let's see, 12 out of 24. And instead of 2/6, we're going to have 8 out of 24. So we're just counting the number of slices there, and then this problem asked us to add those together, so we will. 8 plus 12 is 20/24. You do not need to simplify these problems. Go ahead and leave your answer as is, but you're welcome to simplify if you want. All right, our last page is, not last, but this next page is just expressions that you need to simplify, so you don't have to draw any visuals here, but you're welcome to if you want to. The visuals are supposed to help develop an understanding of what's going on so that when you do a page like this, you can refer back to those visuals that you've used in the past. For each one of these packets, you'll have a page that has kind of like word problems or application problems. So if you're in an addition subtraction packet, you know that these are going to involve addition and subtraction. Really, it's asking you to add all of the numbers that are in the tables. On this last one, it's asking you to either add or subtract the fractions or mixed numbers that are presented in the problem. So hopefully that makes this first packet clear. I'll upload another video for each of the other packets here in just a few minutes.